Hey guys, Mr. B here, and in this video we're going to be going through the Accelerating Marble Lab. This is the handout for it, and there are some pre-lab questions we're going to answer together before we actually get into the lab portion itself. So first, let's just read the introduction a little bit so we understand what we are doing. So it talks about here how acceleration is a property of motion that explains how changes in speed or direction affect an object, and it is defined as the rate at which velocity changes. So that means that if the speed of an object increases or decreases, and or the direction of an object changes, then the acceleration of the object has changed. They give us an equation for acceleration, and let's zoom in maybe a little bit here so you can see it better. They give us an equation. So we have VF, which is final velocity or final speed, minus VI, which is initial velocity or starting speed, divided by time, will then give us acceleration. Okay. It says most often acceleration is used to describe an object as its speed increases. This usually results in a positive acceleration. Likewise, though, a negative acceleration would indicate that the object has decreased its speed. So in this experiment, we're going to observe a marble as it moves through a colloidal substance or shampoo or body wash. And we're going to use our observations to describe the marble's velocity from that, and then we're going to calculate its acceleration and make a distance time graph. All right, so there are some focus questions here, and this is what we're going to answer before we jump into the actual lab portion. So it says, number one, create a distance time graph, distance on the y-axis, time on the x-axis, that will predict the marble's motion through the shampoo. So I'm going to do this on a piece of paper. If you have a piece of paper at hand or something, you can do that as well. But we're just going to make two axes like this, and we'll just have time on the bottom, and we'll have distance on the y-axis. So we're just going to put down what we think a graph might look like for a marble as it's falling through some shampoo. I assume as it falls, of course, it's going to speed up because gravity is going to cause it to speed up, but it might do so really slowly. So I'm going to guess that the graph's going to look something like this. Okay, we're going to have a curve to it, but it's going to be a pretty slow curve, right? Versus something where it's like really curved or like, really fast like that. I don't think it's going to look like that. Because it'll take, I think, a while for the marble to kind of speed up as it goes through the shampoo. So I think that's what our graph's going to look like. Okay, so that's question number one. So let's look back at our handout here. Number two, do you believe the marble's acceleration will increase or decrease as it travels through the shampoo? So I think it's going to increase because gravity is going to cause it to speed up as it falls. So I'm going to say I think the marble's acceleration will increase as it travels through the shampoo. All right, and then question three, explain why you chose increase or decrease. Okay, so I specifically chose increase because gravity, of course, is going to pull it down. And as things fall, they usually speed up, right? Gravity causes things to speed up. So I would assume this is going to be no different. It just will take longer, maybe. Okay, so I'm going to put down something like that. So we'll say I chose increase because I think, or because gravity usually causes objects to accelerate as they fall, and I think the marble will be affected by gravity as normal. Something like that. Okay, so that being said, we're going to move into the actual lab portion of it now. And as we do that, there are going to be some numbers here on this data table that you are going to fill out. Okay, so as you watch, make sure that you write in any numbers that are given to you, and I'll see you at the end for the post-lab questions. All right, so the first thing we're going to do is we're going to measure the distance between 10 milliliter marks on the graduated cylinder. So holding up a ruler, it looks like we have about 2.9 centimeters for every 10 milliliters. So we're going to mark that on our data table. All right, so once we've written 29 millimeters in our first box, okay, or 2.9 centimeters, step 2 says multiply this distance by 2 and write the result in the second row of the data table For the third row, multiply the distance by 3. Continue until you have written distance in 5 rows. So basically what we're doing is we're going to write down the distance that the marble is going to travel through the whole graduated cylinder. So we have 29 millimeters. Let's times that by 2. That gives us 58 millimeters. And let's actually make sure that this is red font, red text. So 58 millimeters. And then we'll go 29 times 3. 87 millimeters for the next one. Then we'll go 29 times 4, 116 millimeters. And then 29 times 5 is 145 millimeters. Okay, so on your sheet, you should then have all of those numbers written in as well. And then we're going to move on to putting the shampoo in the graduated cylinder. All right, so the next part here is we are going to add the shampoo into the graduated cylinder so that it is up to the 50 milliliter mark. So there's going to be quite a bit of shampoo here, but you know, in the name of science, this is oddly satisfying. Here we go. Right up to the 50. All right, so it's probably about as good as we were going to get it. And it's a little bit above the 50, but I think it should do. So, all right, there we go. Let's move on to the next step. All right, so we are going to now take our marble. We're going to drop it into the graduated cylinder with shampoo. And as soon as that marble hits the top of the shampoo, we're going to hit start. And every time it goes down 10 milliliters, we're going to hit lap. So when we're done, we'll have 1, 2, 3, 4, 5 total times. All right, and here we go. Start. Now this is going to take a while. So we might speed this up. We might not. But that's a slow moving marble.
Yeah, I was going to say that's going to take a long.
All right.
Look like.
And time.
Can I stop it?
Yeah, I'm going to stop. Holy smokes, that was a long time.
Almost 5 minutes.
All right, so our marble has hit the bottom, and it has taken about 13 minutes and about 20 seconds or so. All right, so we're going to record these times in our data table, and we're going to move on to the second trial. All right, now for the second trial, we're going to add 8 milliliters of water to our graduated cylinder, and then we're going to add in our body wash, and we're going to mix it up. So to do that, to make it easier, we're first going to add 4 milliliters of water, then we'll add some body wash on top, then we're going to mix it, then we'll add another 4, and then we'll add body wash. That way all of it is thoroughly mixed together, and we don't have any really watery parts with then parts that aren't so watery. So we'll add it into about here, we're going to mix this up, and then we'll do it again. All right, so we now have our second trial set up. We've added 8 milliliters of water to our shampoo here, so it's a lot more watered down. We're going to drop our marble in, and we're going to see how long this one takes. Now, I'm pretty sure this one's going to be a lot faster, so we're going to have to be on our toes. Might even have to slow this footage down so you can see it, but here we go. So, again, when the marble hits the top, we're going to hit start. So ready, set, and go. Lap. much faster. Lap. So slowing down a little bit, but not too much. Lap. Still going pretty good. Not taking 13 minutes like the first one. And lap. We're almost to the bottom. You just hit done when we get there. Almost, not there yet. And done. All right. So there we go. So our times for this one, we have the first 10 milliliters, so from 50 to 40, we had 2.54 seconds. From 40 milliliters to 30 milliliters, we had 5.97 seconds. From 30 to 20, we had 11.62. From 20 to 10, we had 12.33. And from 10 down to the bottom, we had 20.17. So put those times in your data table for the second marble time trial. All right, guys, welcome back. After watching the lab video, we are now going to answer the post-lab questions. So on your handout or your lab sheet in your Google Doc, you should have all the numbers written in here. And if you don't, fill them in like I do, okay? So with this information, we are going to answer the post-lab questions, and there are 3. Now, the first one here, it says, use the data you collected to make a distance time graph for each of the 2 marbles. Now this is a Google Doc. You could draw on it, but it's kind of tricky. So I'm going to do mine on paper. I'd recommend just doing yours on paper too. It just makes it easier. Okay, don't worry about trying to draw on this. So I'm going to switch over to my paper here. Okay, so here is my first marble. And we're going to graph the data points here for the marble as it fell through the body wash. Okay, so I'm going to use the data from the, I'm going to use the data and the times from the lab. I'm looking at my data table right now, so have yours, you know, you just flip the page to the last one or whatever to look at it, or I guess scroll up. So the first marble, the first time was 55.53 seconds, and it went 29 millimeters. So I'm just going to estimate a 55 is probably somewhere about like there. Okay, we're just going to estimate here. So the next one was 157 or 158. So again, we're going to estimate maybe roughly about here, about 158. Then we were up to almost about 300 or 297, 298. So again, maybe something like there. And then we had about almost 500. So our next one was about 500 maybe here. And then the last one was 783 or 784, which is going to be up over here somewhere. And again, we're going to estimate maybe somewhere like this. So if we draw this graph and we connect all of our dots here, our graph is going to look something like this. Let's just make that line a little bit better. There we go. Okay, so our graph's going to look something like this for the first marble, which is interesting. So we kind of have this curve, right? This downward curve, or I guess it's going up, but it's kind of flattening out as it goes. So this is showing that the marble was slowing down. It was decelerating, okay? So that's the first one. We're going to do our second marble, so I'm just going to flip my sheet over to the back side here, and we'll graph our other one. Now I made 2 graphs because this one, the time goes from 0 seconds to 800 seconds, and the second marble only took like 52 seconds. So if I didn't make a new time, axis on the bottom, and we put the second marble on this first graph, it would be over here somewhere, and it'd be like something really ridiculous like this, and it just wouldn't look very well. So I'm just going to do my own graph, or a separate axis. So here's my second marble. Again, let's graph this one too. The first one took about 2.5 seconds, so somewhere about in here. Then the next one was 8.5 seconds, or about 9, so somewhere maybe again in here. We're just going to estimate a little bit. The third one was about 20 seconds, so 20 seconds somewhere in here. Then we had about 32 seconds, so 32 seconds Again, maybe somewhere in here. And then we had 52 or about 53 seconds. Oh, and I realized that my chart only goes up to 50, so let's add just one more in here. So let's go to 55. So 53 seconds is somewhere maybe about in here. And again, we're just going to estimate something like that. So, all right, so if we connect all these together, again, we see almost the exact same graph that we did for Marble 1, right? So Marble 1 had a graph that had that kind of downward slope or that flattening part to it. And Marble 2 has pretty much the same thing, albeit it happened in a lot shorter amount of time. It also was decelerating. All right, so we've made our graphs here for the first question. Let's go back to our handout. Okay, so we've graphed our stuff. So number 2 says, explain the motion of the marbles as they fell through the shampoo. How did you show this motion on your graph? So basically, we're just going to explain what our graphs look like. And our graphs were, downward sloping. So we'll just say the motion of the marbles as they fell through the shampoo was that they were decelerating. In the graphs, this motion was shown with the graphs flattening out as they reached the top. So they had a downward curve to them. Okay? Something along those lines. I don't know why I bolded this. It didn't need to be bolded. Let's unbold that. There we go. Okay, so again, our graphs kind of went up and then they kind of curved down like that, or they flattened out, which shows that the marbles are slowing down. Number 3, based on your graph, were the marbles accelerating? Explain your answers. Yeah, they were. So remember that acceleration is change in speed or change in direction, and it's not just speeding up, it's also slowing down. So we can say, yes, the marbles were accelerating. Yes, the marbles were accelerating. They were slowing down as they fell. This can be seen by the downward slope of the graphs. Yeah, this can be seen by the downward slope of the graphs. Just leave it like that, I guess. So there you go. Yeah, the marbles were accelerating. They were just decelerating, I guess. Instead of positive acceleration, we had negative acceleration. All right, then number 4, use the data table to calculate the average speed of each marble. All right, so this isn't too difficult to do. So remember that average speed is equal to total distance divided by total time. All right, so for marble 1, our total distance, it's for both marbles, our total distance was 145 millimeters. Marble 1 total time was 783.95 seconds. So we'll go down here and we'll say, let's underline this, turn this red again on bold. So marble 1 average speed is equal to 145 millimeters divided by, let's go double check the time one more time, 783.95. So 783.95 seconds. So let's do this on a calculator and let's see what we get for our speed. So 145 divided by 783.95, we get 0.18 meters per second, which is a very, very slow speed. And as for marble 2 average speed equals, it's going to be 145 millimeters because they both fell the same distance. But marble 2 had a time of 52.63 seconds. So let's just copy paste this down here. 52.63 seconds, there we go. And that is going to be equal to, so let's see, 145 divided by 52.63. We get 2. I guess we'll go 2 decimals, so 2.76 meters per second. So if we look at the speeds for both marbles, marble 1 fell really, really slow. And marble 2 fell way faster. But that's because we watered the shampoo down, so it makes sense. So, okay, that is it for this lab. hopefully that helped you learn a little bit about acceleration and doing some graphing stuff and calculating some speed. So, all right, guys, I'm Mr. B. Thanks for sticking with me, and I'll see you in the next one.